I want to factor the polynomial 2x to the fourth minus 19x cubed plus 57x squared minus 64x plus 20. So for this, I'm going to use the rational root theorem. So you always want to take the factors of the constant term, so this 20, and you're going to divide it by the factors of the leading term, the leading coefficient, which is 2. So we have 20 over 2, and you list out the factors of 20. So you want to list out the plus and minus of that factor. Okay, so you're doing 2 of them, and then the same thing with 2, the denominator. Now at this point, you're going to pair them up. So you start with the first number here, and you're going to divide it by each one in the denominator. So this 1 divides both 1 and then divides 2. 1 over 1 is 2, and then 1 over 2 is a half. When you're dividing, you still want to keep the plus or minus. Then you move on to 2. 2 over 1 is 2, and then 2 over 2 is 1, which we already have. Now go on to 4. 4 over 1, and then 4 over 2 is 2. We have that already. Then we have 5 over 1, and then 5 over 2. Next, 10 over 1. 10 over 2 is 5. We have that. 20 over 1, and then 20 over 2 we already have. So we have 8 coefficient or 8 factors written out here, but then we have to consider both the positive and the negative version. So there's going to be 16 total that are possible roots. So your job here now is to test out which one works. The best way to do this is to find one that works, and then from there you can figure out the rest. So by trial and error, you can pick a bunch of these to try, but it turns out 2 is the one that works. So if I plug in 2 here, that's going to be a 0. So I'm going to do syntactic division, and I'm going to figure out what is the factor after I divide it by x minus 2. So for syntactic division, let's bring down the first number. 2 times 2 is 4. Add. 2 times negative 15 is negative 30. Add. 2 times 27 is 54. Add. 2 times negative 10 is negative 20. And then add. So we started off with a fourth degree polynomial. Now we reduce it down to a third degree. And so this is like 2x cubed minus 15x squared plus 27x minus 10. And if you want, you can also do the rational root theorem for this, which should give you fewer roots to consider. So you would just look at negative 10 and 2. So actually, I don't care about the sign for now because we're going to be comparing. We're going to be doing the positive and the negative version of it. Okay, so same story here. And then you would just look at combination. So 1 over 1, 1 over 2, 2 over 1, 2 over 2 is 1, which we did, and then 5. So the list is a bit smaller than what we had originally. So it's always good to plug in 1. So if we plug in 1 here, we have 2 minus 15 is negative 13, plus 27 is 14, minus 10 is 4. So 1 doesn't seem to work, and then if you plug in negative 1, that's not going to work either. But what happens if we plug in a half? So let's try that out. So I have the 1/2 here, then we do 2, negative 15, 27, and negative 10. Bring down 2. 2 times a half is 1. Add. 1/2 times negative 14 is negative 7. Add. 1/2 times 20 is 10. And add. So I was able to get a quadratic now, 2x squared minus 14x plus 20. So 1/2 is a 0, which I can factor out of 2 and get this. Now this is easy enough where I can factor out I can do x minus 5 and x minus 2. So I have to take this equation and then combine it with the zeros that I found above. So I have the 1/2 here, the 0, and then the other 0 is a 2. So if 2 is a 0, that means x minus 2 is a factor. And if 1/2 is a 0, that means x minus 1/2 is a factor. Okay. So I want to combine this with what I have above here, the 2 x minus 5 x minus 2, and what I can do here is I can take this 2 and distribute both of these pieces. Okay, so that would give me 2x minus 1, and then I have x minus 2, x minus 2. So there's two factors of x minus 2, and so that's going to give me x minus 2 squared. And then finally we have the x minus 5. And so this is what the answer is in factored form.